Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is minimize error. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There exists a hidden array A of length n such that there exists an integer x such that ai is equal to 0 for all the values of I that are less than x and ai is equal to 1 for all the values of I that are greater than or equal to x. So to put it into perspective, it looks something like this. We have an array of size n and we have this mysterious number x. All the elements that are before this x are 0, right? And all the numbers at and after x are 1. In other words, as we have seen, we have number of zeros followed by 1 and x is the position of the first one. In particular, A definitely contains at least one occurrence of the value 1. Now we don't know this mysterious value x. Now suppose we are allowed to query the array at most few times. That is, in each query, we'll give an index and find out what is the element at that index. But there's a caveat here. If that element is 1, we have to terminate the process immediately, even if we have queried less than few times. Now, after the process terminates, we have to provide a guess. That is, what is the value or what is the probable value of x, and the error between the actual value of x and our guess is the error here. And we want to minimize this error. That is, we want to minimize the possible worst case error that we can guarantee that if the given queries, we have to find the answer optimally. So we have this array and we have q queries. We will query it until we hit a 1 here. Once we hit a 1, we need to give a guess of g. This g is a ideal guess from us on where this mysterious x value can be. Whatever is the difference is the error here. We want to find out, given the query and given the length of the array, what is the minimum error that we can find. So for the input format, we have t test cases. And for each test case, we have two integers in one line, that is n and q. As for the output format, we simply have to output the minimum error that can be guaranteed. That is, within this error margin, we can always pinpoint where the value of x exists. As for the constraints, number of test cases will go from 1 to 10 raised to 5, value of n will go from 1 to 10 raised to 9, and number of queries can go from 0 to n. Let's see some sample inputs. For the first sample input, the number n given to us is 2 and the number of queries that we can make is 0. In short, our array A will only have two elements, right? And we have to make a guess. Now, whichever guess we make, right, since we cannot make any query, we'll either make a guess that is the first element or another guess that is the second element. The margin of error here is always just one position. So even if we are wrong, the next element is the answer or the previous element is the answer. So we only differ by one. Therefore, the difference between our guess and the actual value can at max be 1. So with a margin of error 1, we can always point out where the value of x can be. Therefore, the answer here is 1. Let's see how we can approach the solution. So in this array A, right, let's say we find out that after querying this element, right, let's say this index is y. This is 1, right? So what do we know about this? Can we predict what would be a good guess to say that this is a value of x? One thing we know for sure, all the elements after this y are going to be 1. And we also know that there exists in this previous elements some index where the first one exists, but we don't know where. So what is a good guess? Let's see. We have the 0th element here and we have the yth element here, right? Now in this range, we have to take a guess. If I choose the very first element, right, I could, if I'm wrong, right, let's say the width of this is d, right? So if I choose the first element and the actual element could be at the last, right? So my error here would be d minus 1. Now if I choose the last element, but x is actually at the first index, again, I'm wrong by d minus 1 length, right? It is very big. So the best answer that we can do here is choose the middle number. So now at both the ends, my error is just d by 2, right? This is the as minimum as we can get. Even if you move any left, the error will increase. So what can we do from this? So let's say we choose a error that we are fine with, right? And let's call this variable d here, right? Now in our array A, if we are able to choose the error of d, so what is our range? As we have seen in the above, if our guess is this, right, then the wiggle room or the error that we have given us is d, right? So even if the value of x exists anywhere in this range, we are fine with it. This is the margin of error that we are good to go. So in one guess, we can eliminate d plus 1 elements, right? Because if this is the case, right, then all the elements here are already covered. So this is the first query in which we can cover the value. What if someone asks us to take another guess? Well, again, we can cover d plus 1 things, right? We can again correct d plus 1 elements. So with this, if we have q queries, we can consider to cover q into d plus 1 elements, right? But if you see, the first set is already covered, right? If the length of my array is less than d plus 1, then it is already within my error margin. I do not need to make any sort of queries. So actually, we can cover q plus 1 into d plus 1 elements. But the question still remains, what is d here, right? This is the margin of error that we are ready to take. But we want to also minimize this as much as possible. So if this term is actually greater than or equal to n, that is, it means cover all our elements, then we are good to go, right? Within q queries, with a margin of error d, we can tell you where the value of x exists. But what is the minimum value of d? So to find that, we can try all the elements, or we can simply do a binary search. Doing a binary search, we can find what is the smallest value of d that we can get and cover this equation. That is, within q plus 1 queries, the number of elements that we can cover will be greater than or equal to n. With this, we find the d, that is the amount of error that we are fine with, and we actually find a minimum value. And with this, we have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and q, then we initialize our lowest as 0 and highest as n. In short, we are doing a binary search here. We pick the middle and check whether this value, the minimum value that we have taken, is a suitable error range. Whether with this, can we cover all the elements and or not? If we cannot, then we'll increase the window, that is, we move our low to mid plus 1. If that is not the case and we have already covered it, then we'll move to the highest to middle. So with this, we are trying to find out the lowest value of the margin of error with which we can cover all the elements. At the end, once we have this, we print the value, that is, the margin of error within which, given the q queries, we can exactly tell the value or the place of x. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and q, do a binary search and find the lowest error of margin with which we can cover all the n elements and pinpoint the value of x where the series of ones start. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.